Hey, what's going on, guys? So we're going to be working on another arc length problem in this video. And in this problem, we're going to try to find the arc length of f of x is equal to the natural log of cosine of x from the point where x is equal to 0 to x is equal to pi over 3. So without further ado, let's get into it. All right, so the first thing we're going to need to do is we're going to need to differentiate our function of x, right? We need dy dx. So y here is equal to the natural log of cosine of x, right? So this is a composite function. And when you're differentiating composite functions, what you need to do is identify your u. That way you can apply the appropriate chain rule formula, right? So in this case, the u here is cosine of x. So we want to differentiate natural log of cosine of x, right? And the formula for differentiating ln of u, right, d dx of the natural log of u is u prime divided by u, right? Which means we need the derivative of cosine of x, right? And that would serve as our u prime over here. So derivative of cosine of x is negative sine of x, right? So our result would be negative sine of x divided by cosine of x. So let's write that down. So we have our y prime, right, or dy dx is equal to negative cosine of x divided by, or sorry, that should be negative sine of x, negative sine of x divided by cosine of x, right? So our dy dx is negative sine divided by cosine, which is equal to negative tangent of x, right? So the next step is to take the square of our dy dx, right? Because eventually we're going to add this to 1 and then take the square root. So our dy dx squared is equal to tangent or negative tangent of x squared, which is tangent squared of x. So we now have dy dx squared is equal to tangent squared of x. The next step is to add 1 to the dy dx squared, right? So we want to add 1 to the dy dx squared. So 1 plus dy dx squared is equal to 1 plus tangent squared of x, right? And if you remember from your trig identities, 1 plus tangent squared of x is the same thing as secant squared of x. So we can replace 1 plus tangent squared of x with secant squared of x. Right, so now we have 1 plus dy dx squared is equal to secant squared of x, and we can substitute the secant squared into this square root function here. So let's do that. Okay, so we're going to write our arc length is equal to the integral from point A to point B, right? Point A being 0 and point B being pi over 3. So our arc length is the integral from 0 to pi over 3 of 1 plus tangent squared of x, right? And we've already identified that 1 plus tangent squared of x is actually secant squared of x. So we'll replace the 1 plus tan squared of x with secant squared. Times dx. Right, so at this point, we're essentially almost done with the problem. We just need to simplify the square root function, and then we can integrate from 0 to pi over 3. So if we take the square root of secant squared, we just get a secant. So we have secant x dx. And the integral of secant is the natural log of secant of x plus tangent of x, absolute value, right? And we're going to integrate this from 0 to pi over 3, right? So this means that we need to evaluate this natural log function at pi over 3, then we need to subtract the evaluation at 0. So let's do that. So we're going to write our natural log of secant at pi over 3 plus tangent at pi over 3 is equal to natural log. Now secant of pi over 3 is equal to 2. So this would be natural log of 2 plus tangent of pi over 3. So tangent of pi over 3 is sine at pi over 3 divided by cosine of pi over 3. So that comes out to be radical 3. And the natural log, we're going to evaluate the natural log function at 0 and then see what that comes out to be, right? Once we have both of these two values, all we need to do is subtract the natural log at pi over 3. We need to subtract the natural log at 0 from the natural log at pi over 3. So at 0, we're going to have secant of 0 plus tangent of 0. And secant of 0 is equal to 1, so we have natural log of 1 plus tangent of 0. Tangent of 0 is 0, so plus 0 over here, right? And this just gives us natural log of 1, which of course is equal to 0. So this entire value here just goes to 0. So our final result is going to be natural log of 2 plus radical 3 minus 0. Okay, so let's write our final solution down here. So S is equal to the natural log of 2 plus radical 3 minus 0, right? We don't need to write the 0 there, so this would be our final answer.